Welcome to Leveraging the Power of F5XC and our leading Big IP Next CNF CGNAT to solve your customer challenges. This is a demo on modern infrastructure deployment and management of Big IP Next CNF CGNAT with GitOps. This is an environment where I'm going to demonstrate how you can leverage F5 Distributed Cloud Platform to deploy, manage, and operate Big IP Next CNF. I'm going to demonstrate CGNAT and Edge Firewall use case. This is a high level of the packet flow. Environments are set up in Singapore DC, except there is a UE client located remotely in Australia DC, and it leverages F5 Global Network to route UE traffic egress via Singapore DC CGNAT. F5CNF TMM will perform the data plane function and then do a CGNAT out to an external router and to an Nginx web server. This demo runs on a Net44 with the LSN pool of 10.10.10.0/24. Here I have a 4-node AppStack cluster with 3 master and 1 worker node. I have a GitOps tools called Argo CD. OpenTelemetry port collects real-time metrics and statistics from CNF ports and being scrapped by Prometheus port. Grafana store and visualize the CNF port performance metrics. CGNAT logs will be streamed via high-speed logging to ELK stack. Let me start by deploying an Argo CD application manifest. Argo CD receive deployments of application manifest and start deploying applications according to my application definition. This is called apps of apps patterns, where the root apps point to the folder that contains the application YAML definitions for a child apps. Each child apps application YAML point to the directory with the application manifest. By leveraging Argo CD sync wave and sync hook, I'm able to order how Argo CD applies individual manifests within an Argo CD applications. Here is how the GitOps flow looks like with parents Next CNF bundles application consists of multiple child Argo CD application manifests. All those applications will be executed in accordance to the number shown. Upon completion, you will be able to visualize something similar in this screen, and Grafana and ELK will also show the performance metrics and high-speed logs. As shown in this Argo CD application view, first, Next CNF based application will be deployed. This consists of deploying all the necessary CNF certificates, VLAN CRD, MAC VLAN definition, and so on. This is the base foundations for the rest of the onboarding. Then, Next CNF DSSM with Sentinel will be deployed. DSSM with Sentinel is a Redis database. It is a CNF distributed session state management where it centralized and persistent storage for each firewall and TMM port. Session states and translation table and many more will be stored in DSSM. It's deployed with high resiliency. F5 Big IP Next CNF consists of a collection of ports. Apart from DSSM, we have CNF controller, also commonly known as F5 Ingress. It controls the TMM use cases like each firewall or CGNAT. It spins up the TMM port, PCCD, IPSD, OTEL, and so on. You will see those ports once it's spin up later. TMM port is the core data plane function. This is where F5 key differentiator. It is a multi-persona cloud-native traffic management microkernel. If you want it to perform as a CGNAT function, you program it via a Kubernetes manifest. If your use case is each firewall or DNS, you just program according to your use case. Within TMM port itself, there are many others components. Just to name a few like debug, TMM routing, and TM route D containers are part of TMM ports. As mentioned in the beginning, OTEL or OpenTelemetry is integrated and it collects real-time metrics and statistics from CNF port, such as CPU memory, interface usage, and traffic processing events for virtual server and so on. OTEL integrate with Grafana and Prometheus. In this demo, Prometheus sit inside AppStack and scrap metrics from OTEL. F5 TMM ports with TMM routing containers will initiate a BGP peering with external router and internal router to advertise TMM outside and inside IP addresses. These capabilities enable internal router to send traffic to TMM port via equal cost multipath as a default gateway, and also advertise LSN pool to external router for the return path. As shown previously, multiple UE clients able to access the Nginx web server via CGNAT CNF, and both routers able to receive those advertised route. All UE clients currently running, and I'm going to start a remote JMeter load testing tools, which located in Australia DC. JMeter will send traffic via F5 global network to Singapore DC CGNAT. In a moment, CNF performance metrics will be displayed on Grafana dashboard. There are individual line graphs that correspond to metrics from 3 independent TMM ports. CGNAT logs also will be streamed to ELK stack via high-speed logging. As mentioned in the beginning, the true benefit of Cloud Native is you can leverage any tools designed for Cloud Native to your advantage. Currently, each firewall is configured to allow all traffics. I'm going to update each firewall rule with GitOps tools to deny a specific UE client. I just need to change each firewall manifest and commit to Git repo, and Argo CD will handle the rest. Argo CD continuously monitor the live state with the desired state defined in my Git repository. Once changes committed to Git repo, sync process initiated, and you will notice Next CNF H firewall applications shown out of sync, and immediately it will resync. UE2 SG will be blocked. H firewall CNF perform as expected. UE1 SG able to connect to web server. Same with UE-AU. UE2 SG blocked by H firewall rules. Now let's make another git commit to revert firewall's rule back to allow all traffics to web server. Similar with previous GitOps process, I'm going to do a git commit with the new rule, and Argo CD will handle the rest. Again, you will notice that Next CNF H firewall apps show out of sync and immediately sync and healthy. Once the H firewall rules apply, UE2 SG back to allow to connect to web server. Prometheus continuously scrap metrics and send to Grafana. CGNAT CNF logs continuously stream via HSL to ELK stack. From ELK, you can now create analytics from those logs. You have seen the true power of F5 Distributed Cloud with F5 Next CGNAT CNF working together in conjunction with modern infrastructure deployment and management tools. F5 Distributed Cloud and F5 Next CGNAT CNF offer multitude of unique value propositions for your use cases, regardless of IT workload or telco workload such as 5G and 6 or private 5G use cases. Feel free to reach out for further discussion. Thank you.